Hello, I'm going to talk to you about a day in the life of a controls engineer. As you can see, I've been around a while. I've got over 20 years experience as a control engineer in electrical engineering, and it is a very rewarding career. Like what I do, I'm having fun, but there's also some times that it's not so fun. So I'm going to introduce myself, and then I'm going to talk about an example success story that I've had in the past, but it was a really good one. And then I'll tell you what I'm after here in this YouTube channel. My name is James Perkins. I'm an electrical engineer. I went to the Citadel in Charleston, South Carolina. I was not a veteran student. Excuse me, I was not a cadet. I was a veteran student, so I went to the day classes with the cadets, but I served prior military, Air Force there in Charleston, and graduated in '92. Went on to start my engineering field and moved around a lot, getting a lot of experience. And for a while there, I was actually working for myself, writing custom software. So my background is high-level programming and also hardware design. And eventually, I got bored. I was working for myself, making great money. And in 2006, I decided to I want to do something different. I want to do something more exciting, and I wanted to get industrial automation. So I had to get my foot in the door. I tried industrial automation early in my career, but I had no experience. And one interview I had was a guy's. I talked to the guy, and he said, "Love to hire you, but you don't have very much experience, and I don't have time to train you. So sorry, I can't help you." And that is the nature of the entire industry. No one wants to train anybody. And the people that survive, like myself, have done so on our own. We have taught ourselves. We've learned by trial and error, which is sad. And only the strong survive. And most of the companies just throw you to the wolves. So here I am. I'm actually in a hotel room. I'm getting ready to go to a job site tomorrow and to download some new software that's already been tested and validated. And all I've got to do is download it and do some preliminary checks. And if everything goes right, I'll be out of here maybe in a couple days. Normally my job's on a brand new greenfield site, which means it's brand new, just been installed, and we load the software. I can be in and out in a week. And that's how it should be. But you see a lot of companies have, I'm going to say, they do a lot of their design in the field, which is totally wrong, because you get bad programming when you do that. Designing in the field. I had one job recently that other people were doing in my office, and they made some decisions, and they brought me in to fix things. So I'll tell you about that story later. But what I really want to talk to you is who I am, and I want to give you an example of one of the projects I worked on in the past. This was, I can't think of what time frame, 2010, 2011, 2012 time frame. It's actually a job that was near my office, and it was at an intersection of a main road in the city, and it was actually a natural gas regulation station to the city. It had a corner lot, and the programmer they had, which happened to be a tech they had, wrote most of their programs, and they told us, my company I was working for, that they had a generic program. They just turned on and off the programming pieces, and that's how they designed it. They got one program they take everywhere, and they just turn on different features of what they do. This is what they told us. After I got into the program, I realized that wasn't the case. There was tons of dead code. There was a lot of code that wasn't written. It didn't actually work. So this gas regulation station, when I got there, I looked at the existing program. I looked at the PID trend. This was supposed to regulate the natural gas at a specific pressure, and they could change the set points if they wanted to. And ideally, it would be a straight line. So I want 30 psi, and it would be, that's a set point, it would just maintain 30 psi even in upsets and stuff. It would control. That's ideal. So I looked at their station, and before we upgraded it, because it had an old processor, and they was trying to upgrade it to a new processor. So it was all over the place. It was not maintaining pressure whatsoever. It was up, down, and after looking at the code, I was like, wow, this is why. So this guy, whoever he was, I never met him, probably did the best he could, probably taught himself, and probably didn't know what he didn't know. So anyway, I persuaded the customer, into letting me write it from scratch. I knew what I was supposed to do. I got all the information from them, and I proceeded to write it from scratch. And there's a lot of some unknowns I didn't know. I had to ask some other people, like, here's what I need to do. How do you do that? And they showed me. And so at the end of the day, or I should say, it was probably, I wrote it in about 2 weeks. I installed it, and then I debugged it. It took me a while to actually tune the PIDs. PIDs, proportional integral derivative. This is what regulates a modulating control valve to control that pressure. But once I did, I finally got it perfect, and the thing was a straight line. Actually, it was, you couldn't even compare it to the original program. They were so happy. And I was thinking, well, I was happy myself. I was able to tune it. They invited me to do some more projects with them. And another project I did with them at another site, I was upgrading one of their old processors and to a newer processor, and I had to translate the program. Well, when you translate the program from this old system, the translation program doesn't do it 100%. You have to go in and remodify some of the specifically the PID logic has to be rewritten. And the way the programmers did it in the old program was a bad method. So I improved the method, and I tuned the control valve. And as I was tuning it, the plant manager was going, this valve works better than it did before. And I said, well, that's as best I can do with this tune. So we took the same numbers and applied it to all the other valves, which is actually the same brand, and they all worked better than the previous program. It's because I improved the PID. Well, anyway, this is knowledge I've gained over my years of experience. And here, that was 2014, 2013, 2012, something like that in that time frame. And here's 2025. I've gained more knowledge and more experience. And my goal with this channel is to provide coaching for PLC and HMI programming. This is what's lacking in our industry, industrial automation, is there is a serious lack of training. I've seen it all my career. I've seen it for myself. I was able to pick it up because I've got some skill and some talents. I'm able to teach myself any program, and I'm also able to interpret other people's programs, whether it was written well or not written so well. And most people can't do that, and that's kind of sad. Well, anyway, I've got over 20 years experience doing this, and I am prepared now. I'm a coach. I'm gonna spread my knowledge out to anyone who wants it, and I'm working on a training program, and eventually going to go out to a full coaching, and hopefully I'll bring back some needed control engineers. I have a framework, a process that I use to write programs from scratch, and I have a methodology, whatever you want to call it, a framework, methodology, procedure. It works. I've used it all the time. It's fun. I'm having fun. Don't get me wrong, there is some headaches at some times, and you got to work through them. But most of the time, I know 80% of what I'm trying to do. And there's just a little bit of 20% of unknown, which is the fun part. I know how to do most of it. Now I just got to figure out how to do the 20%, and I always do. Whether I have to raise my hand and say I need some help, there's plenty of people that's willing to help. There's also plenty of people busy. And all these integration companies, you can call them system integrators, you can call them control shops, or whatever you want to call them. they're trying to make money. They want to do a project, get paid for it, and done. And they're not interested in training, even though they say they do. They want to train. They don't want to train on their dime. So here's your chance. If you are new to programming, or you just want to get into industrial automation and you can't get your foot in the door because you have no experience, I can teach you enough to get your foot in the door, and also more to where you would be so successful you could probably name your salary. And you could move up into management because you know how to write the programs, you know how to design. So my scope is design. I'm going to teach you how to design, which is missing. Everybody coming out of college, if they've taken any type of industrial automation, working with PLCs, programmable logic controllers, or PACs, process automation controllers, technically they're the same thing. You would get some arguments as saying, well, one's more powerful than the other. They're both the same. You can think of them the same. They're just an industrial computer. And every PLC brand is proprietary. You have to learn their software. They're all different. The only commonality is the 5 PLC programming languages. That's ladder logic, which has been around since 1968, invented by Richard Morley, who invented Modicon, the first PLC. And it was a graphical design to mimic relays, contacts, and coils. In my opinion, it's obsolete. Automation is getting more and more complex. You can still do it in ladder, but it makes it complex. There's a lot of programs that would never want to write in ladder. Next one is a function block. They call it function block diagram. This is actually a graphical that looks like, AND gates and OR gates, as you would draw them and see them in textbooks. And then the next one is structured text, and it is just a text-based language. So you have if statements, case statements, for loops, and there's some other loops. And then you can grab any type of internal function and write it with structured text. And then there's sequential function chart, which uses structured text as one of its main control languages, but it's a step engine. And you need a step engine for machines, designing machines. If I was designing a machine that had servos and stuff, I would use a sequential function chart. However, there's a lot of people that are scared of it, don't understand it, they've never used it, but it is powerful. And so that was sequential function chart. And the last one is instruction list. And you can think of it like assembly language, which is a low-level language. You would have like 4 registers. You would stuff the number 2 in one register. You would stuff the number 2 in the second register. And then you would sum it up in the third register. That's really low-level. It takes a lot of work to write any type of logic. And I'm hearing that they're talking about doing away with this instruction list. Now, the standard is IEC 61131-3 is the standard for PLCs in the 5 languages that I just stated. And there's another standard that's coming out. I'll talk about that later. But these are the 5 languages. Today, I wrote the program and the HMI. And let me give credit where credit's due. I had help. I wrote the original program. It has grown since then because of the company found bugs with their process. They improved their process, so we wrote the code to improve that. And I had others that was working on HMI system. I told them how I wanted to design, and they figured out how this particular program, how we would make that happen, and they did, and we moved forward from there. So it's been building over the years, but in a sense, I wrote all of it. But I had help when I needed help. And some of the help is defining how it's supposed to work, how that process is supposed to work. You should get that from your customer and any experienced people in the same career, or I should say the field that you're working on. And everything's a process. You hear word people talk about machine design and process design. Technically, it's the same thing. The difference is in a machine, you're actually moving servos and motors and mechanical components, where in process you're actually doing a step-by-step process, which kind of machine is still a step-by-step process. You got to do step A before you do step B and C and so on. But there's different control or different logic you have to write. So that's what I'm about. I'm working on a coaching business. I'm tired of hearing about all this lack of training because I see all kinds of bad code out there. I've also seen some good code, wasn't bad. So I'm not throwing everybody on the bus, but it's obvious that people don't know what they don't know. So I have a process, I have a framework that works. I can write a program, including the HMI, from a blank sheet of paper. And I can also take someone else's work and understand it and maybe continue their process once I figure it out. But that takes time. That's time is money, of course. Like they always say, it takes time to learn somebody else's program. And it takes time to integrate something in it so you don't corrupt what's existing. So my main focus is going to be teaching design from a blank sheet of paper. How do you start? How do you think? How do you come up with different concepts? And I have a proven system. I've been doing it for years. And here's your chance to pick my brain. And so this is the start of my channel. And we'll see where this goes from here. I'm going to give you some tips and tricks that I know. I don't like to call them tricks. But tips, design tips that they don't show you in college. I mean, if you took this class in college, they would teach you the programming language, and that's really all you get. They don't show you methods or procedure or a framework to build it from scratch. And on top of this, I'm going to show you how to do simulation. Now, this is a touchy subject with many customers. Simulation is when you simulate the entire project as if it's running. So you're able to open and close valves. You're able to start and stop pumps. You're able to, whatever you're trying to control, you're able to simulate it and test your logic. Now, the catch is you have to be able to take out your simulation and still allow it to work. And that's the issues. I know one company that I designed a system for that had problem with their other integrators in the past, where they would simulate the project and it would work great in the office, and when they took out the simulation, nothing worked. This is because they built their simulation within intermixed with their process logic. That's not the way to do it. I can show you a proven method how to do it to where you're testing 100% of your code, and or logic, however you want to word it, and then all you have to do is go turn off your simulation or remove it, and everything still works. And you download it and commence the testing. There should be no reason why you would go to any project and spend 4 to 6 weeks, 10 weeks, a month designing on the fly. That is just the wrong way to do it. And there's so many integrators do it that way. And so many people get burned out because they're stuck on site for weeks on end. And that's just not the way to do it. So you want to advance your career. If you're new to programming, or you're intermediate, or you just want to know my process because you have your own, and maybe there's some stuff that you're struggling with. Let me know in the comments below what you're struggling with, and maybe I'll make another video of that specific answer, or another method of doing something. Let's see. I already told you the examples. So I got many Air Force war stories, but that's a different topic. But I've got plenty of projects that I could talk about. I've got plenty of bad programming that I've seen and that I had to fix. And I can tell you all my successes, and there are plenty. And so far, I'm having a great time. I don't plan on stopping anytime soon. So, start my channel. I'm going to call it JPC University, because I'm going to do more than just talk about design. I'm going to talk about the programming languages and how to leverage them. If you have a toolbox with just one hammer and that's all you have, then you can't fix much. But if you have a toolbox full of tools and you know how to use those tools and integrate all of them together, you can fix a lot of things and make your life easier. All right, sounds good. Thanks.